Well, again, I think this is going to vary from device to device. Right? Like your
Yeah,
TV is going to be something you probably want to keep on all the time. Whereas, like again, anything that you're like a scheduled kind of program, you can probably check once every 5-10 minutes.
Yeah, and then again, going back to the use case question from yesterday, as well as how people use those devices, we might want to have customized cycles for the apes anyways, right?
Yeah. Anything that you want to be able to control remotely, then it has to be on all the time. There's no alternative.
Yeah, there's no way around that.
Anything that has a dial-like functionality.
Yeah.
But the other option is that now it's going to pretty much have to be on all the time. But the way that we handle the data is also going to vary from client to client. Like we don't want to be doing inserts into a database in Glide and then have a query come up every like couple seconds and then push that over to IMP and then push that down to our device. In some cases, we should throw it onto like some form of service broker like queue so that it does that insert at a later date. And we send that information straight to IMP so it doesn't touch the database and we don't have that overall latency because we already have a lot of latency between the two clouds.
Yeah.
So that's your example for something like a TV or an oven. Like going back to yesterday's discussion, the first thing this person's going to do, pick up their phone, walk over to their oven, play with their little dial, and if they don't see immediate interactivity and watch that temperature go up and down, they're going to think this is a lower quality product. And
that's the first thing they're going to do.
Straight up, that's probably the first thing they're going to do. Like,
how long do you think the latency would be?
You're looking at least probably 200 to 400 milliseconds just because you're going through two separate clouds.
The one thing though that I think Tony mentioned yesterday is that if the IMP cloud is on AWS and
we don't have to go
cloud
outside.
is on AWS, like all the curveballs he threw about China and all that aside, you would get an advantage.
Yeah. So if they're both
inside the same,
if we're lucky and they're both on like the same rack, like if we'd set it up that way, the latency could be as low as like probably 200, 120, right? Like 120 in a perfect world. So if we got like our China connection there, where we were talking about having our third party, and that's also going to affect the technology stack and how we're going to end up doing things because it's a lot easier. So going back to the distributed network solution, because we're going to have different servers for Asia, different servers in North America, different servers for Europe, just because we want to be able to ramp up and ramp down the appropriate service. So we have our co-location and we have the right service, so that we're not paying millions of dollars for services that we're not using. So
it reduces latency too.
It reduces latency, and B, we can choose to ramp up and ramp down the appropriate service and handle the requests in like a reasonable time frame.
Is there a way to consider that when we scale?
What do you mean?
Like keeping a low latency.
So that's it. We're gonna have to have distributed. We're gonna have our content distribution network or whatever. So we're gonna have different networks like in these different locations. So East Coast of the U.S., West Coast of the U.S. Like we can go as granular as we choose to, but we're looking at least 3 like time zone like server depots. Whereas we might.
Chris earlier mentioned security or even authentication over all these multiple layers. And then the additional thing would be that's multiple points of failure as well, or data loss.
Yeah.
What about those kinds of concerns?
So, as far as servers going down, Amazon went down a couple months back for an entire day, which takes up quite a bit of the internet. Netflix goes down. Like half of the startups go down. So, like if we're okay with that, fine. But the other option is that maybe if we go with a more granular approach, because I think it was on like East Coast of the U.S. or sorry, West Coast because it's California. West Coast of the U.S. going down. So we could presumably have some form of replication across multiple data centers, so at least there's one failover. So like West Coast covers both East Coast U.S. and Western Europe kind of thing. But to kind of mitigate that, even though there'll be increased latency during this downtime, it would at least allow your devices to continue to function.
I mean, you got to plan for that.
Yeah.
But I mean, it's much more likely that one of our services goes down by itself
without
the data service going down. Like I think that's where you got to worry about.
Well, this is where we run into things like we have our service broker when we're deciding if we're going to put in a different like our general storage for big data, or we're going to do some form of memory like SQL.
Like, yeah, we got to worry about the servers for sure, but it's the application redundancy. Like, I imagine you would have, right, like you even said, you have your service broker, you have a web server, and you have maybe multiple app services running. You need to make sure that those those are redundant.
Well, you're
themselves.
building this to scale, so we're
Yeah.
service-oriented architecture. He's talking to B, and we don't. And
Yeah.
that way we can choose to ramp up whatever service is
Yeah.
getting pounded, right? Well, like, there's no way you get it perfect the first time.
No.
So once we start playing with it, as long as we write our services properly, we can choose which ones to scale up, which ones to scale down, and look at that. As far as our storage goes, we kind of have, we kind of got this, depends on how you want to approach this. So you've got your general storage, or quote big data. This is going to be your analytics, that kind of jazz. So
Probably the things where latency doesn't matter as
Yeah.
much.
Yeah.
And realistically, we can even have like device history. So there's like I turn on my phone. First thing it does is it says glide. User X is turned on, so it pulls out whatever information from general storage and moves
Yeah.
us into some form of memory cache, and then establishes a connection with the device. The device probably has a local cache as well, just so not that local cache means anything, only to say here's what we last showed you, so like at least it looks like the interface is responsive immediately, even if that is kind of outdated. The time you'll see that be outdated is if I have multiple devices controlling the same pieces of hardware, because like if we lived in the same house and you change the oven to
Yeah.
500 degrees or whatever, and last time I saw it was 400, it might be out of date, but at least I'm showing you something immediately.
Yeah.
Second I turn on my device and I pull up my Glide app, it turns on, pulls that into memory, and then depending on my device type, whether it be something that requires immediate feedback, your television, your stove, those, that's just like, well, it'll go straight through our system, it won't touch the database, it'll stay in memory, and it'll just do, well, queue inserts onto our service broker. Now,
So there was the data that we would be analyzing question, and just information about hey they heated a pizza for 10 minutes, or the fact that they turned it on or off, or they washed their clothes at midnight, that kind of stuff, which wasn't super high priority. And even if there is a queue or a scheduling so that the information they see on their device, like their phone or their tablet, is delayed by 10 minutes or 15 minutes, but they see the previous analytics, like you were saying that there's some memory in the device itself too, right?
yeah.
So for those kinds of cases, I can see that there wouldn't really be a huge problem if there was a delay, just depending on the use case specifically. But then what do we do with the real-time kind of stuff where, sure, okay, I looked at my last wash cycle and I now want to control my washing machine in some way and change the type of cycle.
Or
That's something that needs an immediate reaction.
Yeah.
What do we do for those kinds?
I think the most important use case for that would be something like safety, where you're away, you're at the cottage, but you left your oven open, for example, your oven's on. You might want to turn that off. So that would be probably a critical example of that.
Well, not in. It's similar related. When we were doing the call routing, like the 911 stuff, everything was queued, but it was
Yeah.
prioritized, right? So
Yeah.
obviously your call, like anything related to the routing of a call or a call, got bumped in priority. But we also track like logs, right? So
Yeah.
you want to do
Yeah.
certain logs are important, right? Like in that space, you want to have like call logs so you can audit stuff. But like timestamp logs of I call this method versus that method, that got bumped
Oh yeah.
down.
Yeah. So like debugging logs versus audit logs.
Like actual audit logs. That's where I was looking
So then on our side, essentially controlling the priority, and so some of the real-time stuff would have the highest priority possible and be one of the first few messages making it to the imp cloud and then to the actual device.
for. Yeah. So the only difference is that we had everything running in the same data center. So the whole cloud thing, even if it is priority 0, you still run into it bouncing around.
Well, the problem is you have too much stuff in priority 0 then.
Yeah.
It's probably, yeah.
So there's
Yeah.
The other issue is that you control priorities in the Glide cloud, you have no control over it in the end cloud.
That's right.
So
Yeah.
Yep, that's something I was wondering.
So there's
And there's no way to communicate directly
No.
to devices as well.
No.
So it has to
We've
be-
been talking about the Glide cloud, but are we just taking it for granted that these billion devices, the in cloud will just scale just fine with that?
Sounds like we are really good partners.
Yeah.
You should find out.
It seems to me that whatever problems we face, the in-cloud will face also, and possibly even more.
Yeah.
Because, well, presumably Glide isn't going to be the only thing using IMP,
That's right.
and whatever smarts we add to filter out stuff, well, IMP won't have.
Yeah.
So there's certainly a risk with the mCloud and having to rely on that is kind of like a black box.
And at the same time, if it's going fine for the IMP, well, what are they doing? What are their tricks?
Yeah.
Mhm.
Because there's a knowledge base there, right?
Yeah.
Is there a model that we can learn from?
Yeah.
What about, might be good to also look into problems they've had in the last bid, right? There's the cloud is being used even.
How many devices does it have right now? Do you know?
I don't know. I'm not sure.
If you read anything in their website.
I don't know. I've seen a couple of the things that it's actually been used on, and it seems like it's in
Well,
a large number of
they
stuff.
used it for the
light,
Budweiser.
the Budweiser
The
light.
Budweiser.
Oh
smoke
yeah,
light.
the winning sirens are.
Yeah.
How many of those are in existence right now?
I wonder what the
Thousands.
latency is for that.
Yeah.
Actually, I'm
Yeah.
curious to know that.
That's fair.
Yeah.
Yeah, so it sounds like there's at least a Budweiser for us to study out there.
Yeah. Yeah. Yeah.
Sounds like just
back to beer.
perfect.
Yes.
We always come back to beer.
We should get some for the office. We'll get 6.
Yeah, we ran out.
It's a case study, guys.
We can fix
No.
this.
Yes.
We can fix it.
Learn architecture.
So,
Case of beer study.
do you guys want to talk a bit about like actual technologies like AWS?
So AWS, Nathan's used in the past. I went with Azure, but it sounds like we're already into AWS, and just for latency purposes, we'd stick with that. Based off the discussion yesterday with Tony, it sounds like there's the China version of AWS. That actually kind of scares me. Not from like a technological standpoint, but like we can use a lot more of AWS if we stick in their stack, right? Because like at least with Azure, it's easy enough to ramp up a box, and they'll handle like the sharding of information distribution as that load goes up and down for us. Whereas if we decide to go, if we write our own and we go with AWS and we use like virtual machines, it's going to be a lot harder for it to. We're gonna have to ramp up an entire grouping of servers as opposed
Yeah.
to a singular. Like we're not going to have that fine control.
Yeah.
So there's going to be some performance loss there with the Chinese version.
Well, there'd probably be more exploratory work. Like, there's all kinds of stuff coming out now to help you with that, right?
Yeah.
Like Docker and Vagrant and all that kind of stuff. But I don't think there's been anyone here, like, just to be 100% honest, who've used it on an actual project, right? Like, okay, cool, I've used it. You know, Shane used it to set up, some test stuff, but have we used it to scale up
Yeah.
a solution like this? Well, if we used AWS just as a pure machine and then ran,
EC2.
and then put everything else on top of that.
So there was also the talk of, Martin Larochelle brought up.
Oh, the QNX Cloud.
QNX Cloud, yeah. Yeah, so right now it's in beta. It's really interesting stuff. It's they're big on user permissions.
Of course, they're BlackBerry.
Yeah. No, definitely. It's one thing that we wanted to look at. A few notes here as well. They do have, what was it? Elasticsearch. They
Yeah.
have that capability, which is one of the things they're selling as well.
So
Could be an option as well.
So that would be something like we'd be running for kind of our real-time queries instead of using some traditional.
But, that would probably have more value here.
Yeah, well, because we can keep Elasticsearch entirely in memory, and we can build a cluster of that, and that'll be relatively quick.
How much real-time querying would be done though, realistically?
Well, yeah,
Like,
and
user-driven?
yeah.
Would you be querying information at real time?
Well,
Like a third party or you yourself?
Or I meant like not fetching information in real time, but making demands, like trying to control these devices from a mobile, for
so like
example.
we're pulling up the
Well, I
information.
wouldn't make the assumption that it would only be real-time control, because control means you have a certain amount of information, right? Which means that you would query to find the current state, at the very least, of whatever device you're trying to control.
Yeah, and you need to update that state more often than you're going to want to
Yeah, so you're
change it.
Yeah.
Mhm.
So that'll
Depends on the use case.
Yeah.
realistically, it'll just.
I mean, we can be
exist for
smart
30
about that
minutes
too.
at a time.
I mean, this is such a general discussion, right? Depending on the device, the actual use cases that we decide should be supported by whatever the platform the user is using, tablet or phone, and whether it's their washing machine or microwave, I'm pretty sure there's going to be some cases where it can be a small amount of real-time querying rather than a lot of it, right?
Mm.
Yeah.
Is the focus of the Glide application going to be on controlling devices so much as gathering usage statistics and things like that, which is more of a read-only?
Well, the use of statistics is something that presumably they're going to want, right? So that's something we're throwing into like a Cassandra database, is something for a little more long-term storage that we can kind of set it and forget it and don't have to worry about that response time, right? We just queue that up and kind of don't care. And then, like other companies, like mentioned yesterday, like Navsol or Hertz, it's like they took that information that they gathered from all the GPS units in the car,
Right.
and they sold that to another company,
Yeah.
which is,
Yeah, data gathering could be
Yeah.
worth a lot.
and that at least would offset the cost of these servers, because they are. It doesn't sound like there's a monthly fee to stay in the Glide client.
Well,
So
no, I mean the.
What was the term?
data-
Cha-chang?
no, it's the Kachow.
Kachow.
Yeah,
Kachow.
cars, the cars.
Sorry, Chris, you were saying?
Just that the data gathering could be a main focus as well, rather than controlling.
Well, that's certainly something we would cover, right? But it's a different.
It's the
problem.
easy problem.
Yeah, it's the
in
easy
a
problem.
way.
It's just we,
I mean,
we need large storage, and we want our millions of records, and it's just an insert. And this is something.
Yeah, that's
that
only the write you need to worry about. As far as reading, that's going to be once in a blue moon, but you're going to actually be looking at it to aggregate it.
Right. You just export once from MapReduce, build your pretty picture. And,
Yeah, I was gonna say the good thing you brought up the MapReduce bit, because again, depending on the use case, yes, some of the time, if you're just gonna sell that data, then yes, the storage and performance and stuff that comes with that, it's a problem we've solved. But it is something that to consider, right? Because if it's just a whole bunch of data and only once in a while you're gonna do that MapReduce on it and figure out and update a little graphic, sure. But depending on the case, and depending on how much data there is, there's performance on what the user will be viewing as well. And latency we've spoken about is like cloud to cloud, or performance on the actual database itself.
So
what about the devices that the user has? Like how much can they take and what can they even show, right? Like
So
that's another.
it's not that bad. So Sierra was 90 million rows, right? And as long as you set your keys properly, like your composite keys, you should be getting responses of like 10 to 100,000 results in like less than a second. As long as your keys are properly done, which is really easy enough to do. We probably have 2 or 3 separate tables, one for like the user's history and one for our personal analytics, which would be totally separate, that they necessarily wouldn't want to look at, or we wouldn't want them to look at.
So do you know if there's going to be a portion of this that's like a public-facing web app? Because we're kind of just talking about like how the back end works for like just tracking data, but like do we need to build a web app portion of this where people could log in, like you would interact with this data? Do we even care? Like
We might not be building it, but it's always something that someone will want at some
Well, we're,
point. Like you want a dashboard for your home,
yeah.
basically.
Right, well, that's why we just go with services. Everybody can consume service at this point. Every device can consume services.
I would go further too, like especially if you look at the selling the data side, or even let's say whoever forms Glide, and there's a sort of, and it's a partnership with Samsung, right? There's some data in there that's actually important to them that's not important to the actual users whose home it is that has the devices. So kind of like the Nokia prototype sort of thing, where there might be visualizations in a completely different web app that might want to analyze and see this data in a very, very different way.
What kind of technological considerations would this bring if we would have to build one, for example?
WFB?
Web
front.
Oh.
Oh, like what Mike
Alright.
was saying, you just want services, right? Because assuming there's going to be an iPhone app, an Android app, a Windows Phone app.
Without even diving in like
Yeah.
responsive design or anything.
Yeah,
But you don't care as long as it's a service. Anybody can consume it.
Yeah.
Like that's how you do every web page now. Service.
So and then you use like framework on the front end.
Yeah,
you can
like
handle.
Angular knockout.
Yeah.
Knockout's clearly the choice right
Okay.
Well,
Sure.
We have not settled in that HTML5 chat.
Oh, you were lucky that I
thought
didn't
there
get
was a
asked that at
battle
the
there,
pizza
yeah.
lunch. I was going to ask that question at the pizza lunch.
but yeah, so you would just do it all as a service, like public-facing service, internal services.
You could write a
for-
single-page app that just consumes these services.
Yeah.
Like that's the easy
But
part.
I think part of Martin's question is that service.
Yeah.
What does it imply to
Yeah.
the shape of the service that you
Yeah.
want to serve a web front end?
Yeah.
Like in
Or
terms
any
of the,
front, or
in
an
terms of the
iPhone front end.
sort
yeah.
of queries you want to be able to do
Yeah.
and do efficiently is completely different than the
Yeah.
just analytics thing.
Yeah. Well, we're gonna have multiple databases depending on what we're gonna be showing the user, what kind of analytics history we're looking at keeping, you know. And realistically, we'll probably even have some short-term live, like every input that went into that device, just like time to live, set that to like 30 days, and then let the Cassandra database auto-prune itself so it doesn't grow out of control. Because we're gonna get nicked for storage of data, data coming in, data coming out, RAM on the machines, processor usage. Like that's what AWS is. So you need to make sure that we don't keep things forever that we don't need to keep forever. Right? After 30 days, do we care? Probably not. For something like logging, right? It's like run things in off hours, make sure we spin things up and spin them down accordingly, shard that information properly so that it can be scaled out nicely, make sure your keys are good.
So would you do something like what we did before, like on Sierra, where you store some of the stuff in an SQL database for instant access?
Yeah, so in this case, we're doing something different. So instead of using like a Postgres server, we'd be using something like Elasticsearch that's entirely in memory, because things like Cassandra are hard, like those NoSQL databases are hard drive intensive. So granted, we can throw like solid state drives at that, but the performance there is not going to be instantaneous. You're still got latency. Like even if you, in a perfect, like we had like, 50,000 results coming back when somebody was scrolling around a map immediately. And our response time was maybe 200 milliseconds on the upside. And that was with mediocre hardware. So like you can get good response out of it, but that was highly optimized. So if we push that all into memory, because we can, especially because like this, although there's a lot of data, and it's big data, we're only handling like maybe 100,000 items at a time, as opposed to in that case like 90 million.
Yeah.
Right. So we're handing back like 60,000 items at a time out of 90 million. In this case, we're handing back 5 or 6. So the big data is easy. Sure.
Yeah, Tony had mentioned Cassandra or Dynamic DB.
So this is it. Like if we could just stay in AWS stack, depending on how that Chinese server goes, DynamoDB is kind of what we end up using. But if we do have to support that Chinese server, we're gonna have to kind of change how we do like virtualization in AWS, and we're gonna probably end up doing something with Cassandra because we've got a lot more experience with Cassandra based off DynamoDB. Documentation is good, so that would probably be one of our front runners as far as like memory queries go. We could write our own memcache garbage if we wanted to, or we could go with like Elasticsearch, or if we really wanted to, we could do some form of like Postgres and SQL and let them optimize it for us if we gave them a big enough box. But those are things you have to scale vertically as opposed to horizontally, right? So again, as long as we're distributed by like West Coast and East Coast, Singapore, China, well, East Coast, China, West Coast, like I don't know how you divvy up China. There's billions of people there. I don't know how you do that. But you need to see numbers on how China works.
Well, there's rules and
Yeah, so that's why we potentially can't use AWS in China, but still, like distributing your services in China is going to be entirely different. And like
it'd be a challenge in itself.
India's going to be another example of like you've got another billion people there. How do you divvy that up, right? Like north, south, east, west. You're going to have in that case, you're still going to have to divvy that information up. Like North America is easy. We've only got 500 million people. That's a small number. India's got 1 billion, China's got 1 billion.
Yeah.
Cool. China's got tiny families, so it's a lot more households, relatively speaking.
That's actually a variable, yeah.
Yeah.
Because that's a key here. That was the point I was making yesterday, that number of devices connected isn't necessarily the right metric to be using, because the user isn't going to be talking to all his devices at the same time, isn't going to be using all of them at the same time, so it's really the household that's
Yeah, like
To a certain
there's an
point,
intermediate
the unit.
Yeah.
So there's the other trade-off though is like I've got 2 or 3 phones in a household. Like in North America, we might have like some families have like 12 people, but 7 or 8 of those people have an iPhone.
Yeah.
So like they might be connecting more frequently to the server. I don't know. Whereas like your usage statistics for China.
It's kind of and it's a many to many. Like I can have 3 people in one household controlling the same device.
Oh, that's going to be fun.
right.
yeah, like that's.
And one person connecting.
The second that one of those is on, though, that entire set, all those devices need to be
Fighting
shut
with the remote to a whole new level there.
Yeah, that's where you need role hierarchies. Father,
Yeah.
son, override TV setting.
Yeah.
How about resolving when both the mother and father decide to control the same device at the same time?
Well, that's it, right? So, like, dad owns the TV, right? And mom owns the stick.
Stop.
I'd probably talk about that in another meeting or something. But no, it's
But, like, should dad be able to control mom's TV? Probably not. Like, he would set individual devices.
Yeah, but where does all that
Family
stuff happen
TV,
though?
And let's say, one person
Like,
is
do you-
only there physically watching.
Do you have ownership of devices?
Yeah.
At the same time, though, as a parent, I want to be able to shut off my kid's television at 11 at night because that kid should be asleep.
that's actually a legitimate concern, Aisha, because if I'm doing laundry and then someone else decides, oh no, I'm gonna stop it because I think it's on, like they're,
Sure.
that's an actual
But
use
there's-
case.
those are kind of metrics that you would track in, like, the slower database, right?
Yeah.
You're like, this is the last
Oh, yeah.
time it was
Oh, yeah.
run, this is who
Oh, yeah.
run it, this is how long it's going to run for, this is what the expected completion time is.
There's no like real-time steal device battle going on there. It's a metrics thing.
Like, we need to...
It could also introduce interesting dynamics in how to prank your housemates.
Make a game out of it.
Sure.
Always good.
But like you got two different pieces of information. We need that immediate feedback, which is going to stay in our memory and our real-time queries, and then we've got like those metrics, which they can wait 3 seconds for those metrics,
Yeah.
right? And they're probably okay with waiting 3
Yeah.
seconds for the metrics. They're not going to walk up to the stove and be like, "Ha, see, it was me that changed it."
Yeah.
Like they don't care.
Yeah, but the computing, like, so there's a lot of stuff here, like the resource contention issue of a TV, for example. Do you handle that in the cloud? So like mine comes in before yours, right? Like
Yeah.
you have that whole problem. It's not just routing messages anymore. It's deciding which message goes through, and that's a tricky problem to solve, right?
Mm-hmm.
And then you
It
just
sort
solve.
of breaks the assumption that you push a button and it doesn't matter if it's going to take a couple of seconds to do it because you can just pretend you did it. It's if there's going to be contention if what you do can not actually take place,
Yeah.
then
And like the stove thing's a prime example, right? Like let's say we're roommates,
Yeah.
and you're like, "Oh crap, I left the stove on when I went to the
Yeah.
cottage, but I'm cooking."
Yeah, you're actually using it.
Yeah,
That's are like this person was the person that sent the command at this time. Like that should be enough to kind of solve that for you, right? It's like Nathan's using the stove right now. He's cooking this, and he used it 5 minutes ago. So like I can give you that information back.
yeah.
So that's probably something we want to store in our general store.
Yeah,
so
like, if
that's,
you want-
that's assuming that everybody is using his phone to control the stove.
Yeah.
Okay,
Which
Yeah.
is
but
at the
that's-
moment somebody turns
Sure.
a knob.
Sure, but like if I turn
Yes,
it off,
that's
I
true,
still
yeah.
say like manual input at this time, right?
Yeah.
It's just
And so
Yeah, if the device is intelligent enough to tell you that, if I go to turn off device X, I can see when it wasn't turned on by who.
yeah, or like just like manual override at this time.
Yeah.
Yeah, exactly.
so maybe it's a problem you don't even want to
And
solve.
you're
in
also
the
saying that
cloud.
Exactly.
the state machine is a little bit more complicated for every device, right? You're actually physically trying to store what is that state of the device, so the last input, whether it came from any out of the 7 household devices, or whether it was someone physically going up to it, we
Yeah.
don't know who, and doing something to it.
But I think for something like this, like we can't, like every household will have to establish some rules, right, on how they use the devices and control them. The challenge is giving them information that they need to establish those rules, right?
So I think TV is probably a more fun example.
Yeah.
But like, yeah, because like that's the one where you're gonna have your arguments. These people still argue over that stuff,
Yeah.
right?
PVR.
Yeah.
Mhm.
Well, I wouldn't
What's
go so
recording what?
with those arguments, but I think that the way that regardless, even when we simplify, we will still have to solve that problem that Nathan was mentioning, which is which messages, I guess even in any kind of queue, resolve to being the more priority one that actually makes it to the
So
device.
for like an initial
What
release,
kind of message you
do
send
you
back
care?
to whoever tried to control it.
Because for the initial release, we just want to make sure all the messages arrive, right? Like something like volume, they'll probably like 5 or 6 of this will just have a queue that we send it after a certain,
Yeah.
right? Now, whether or not the device can support any form of queue, like you say 225 kilobytes?
No, it could support a queue on the actual device, but the persistent storage is really small.
Okay.
The actual
So,
device
so what's
has,
the memory then? Like, do I have,
I don't know, I looked it up last week and I kind of forget. But it's,
Okay.
it's large, it's in the
Okay.
hundreds of megabytes.
okay, so we can hold a queue, and we can say here's volume up, volume up, volume up, volume down, channel up, channel down.
Yeah, you batch things up, and I mean for things like your dishwasher or whatever, you batch it up once a day in the middle of the night. You
Yeah.
upload.
Yeah. Yeah. Then you'll have to clean the queue at some point.
Well, there's just a maximum size of the queue. The question is, which one do you pop off? The newest
Yeah.
one or the last one? But
That'd
that's
be a problem
that's-
in itself.
yeah.
Like,
But we've basically got 3 kinds of devices. We have our dumb device, like our blender and our
Mhm.
microwave, which are just recording statistics.
mhm.
Right? We've got our schedulable devices, like our
Washer, dryer.
washer, our dryer, like cook stove, or what are those, like slow
HVAC.
cooker.
Yeah. Yeah, AC and all that
Yeah.
stuff. And then you
And
got the
we've
real
then
time
we got a real time
fight over devices
Yeah.
like the TV.
Yeah.
Yeah.
So I think
Robots.
you're gonna handle each one of those a little bit differently,
Yeah.
realistically, and you have to.
Okay.
So like TV, we just need a set of requirements on what, like, how we want to handle that, because I don't think that's not our decision. But we just need to be aware that there's going to be that problem there.
Any other big ticket item you guys want to talk about?
Scary part is the fact that, like, I don't know how much control we have in that in cloud. It doesn't sound like any.
Yeah, you have basically no control over the
Well, I mean,
or
because
the
because
firmware for itself.
because Glide is spinning off from IMP, right?
Yeah,
so like
that's right.
presumably they're at least they have some input
So
into
it's
how
a
that
new
cloud's
entity
gonna work.
that
Yeah.
focuses on this use case.
So, like, I'm not saying that we personally want to be able to manipulate things in the cloud. We just need to know, like, how certain things are going to work, how it's going to handle this or that.
What kind of modifications are there going to
Yeah. Can we
need
Yeah.
to do
can we be
to support that?
And if it is like the way they're spinning off, it's quite possible because they're going to integrate with other partners, like washing machines isn't what
Yeah.
it does. That there might be changes they're happy to make too to support that.
Yeah. well to drive up their business for sure? Because like, regardless, it's a partnership. So like at least you're going to be able to ask for something. So the question is, can we get the IMP cloud, like the rack or some of the racks, like beside the Glide servers? Because that's going to reduce our latency and our overhead.
Yeah.
Again, it sounds like IMP is in AWS in China. Is it still in AWS? Because we talked about having an AWS site in Hong Kong. Clearly, we can't put 1 billion people into Hong Kong, but like, what is this Chinese server? What is that?
Yeah, to be determined, really.
Yeah, like I like it. Are they spinning off all of AWS's stuff? Is like all
Not sure.
stolen? Like I don't
Not sure.
know.
Not sure. Okay. Yeah,
I find
confirmed.
a lot of investigation
Yeah.
questions.
So exactly at this point, I know this is something we can do. It's just a matter of getting answers to many of those questions and clarifications, really.
But regardless, we're going to have something that can handle a lot of connections at the edge of the Glide cloud, whether it's direct connection or the IMP cloud.
Both
right?
Glide and Glide and need that, right?
Yeah. So it's kind
Speaking as someone who basically has no worthwhile experience in the cloud, how do you validate that sort of things? How do you validate that, yes, this is going to scale before actually launching and
It's a lot of
rumbling?
a lot of testing, like
Yeah.
automated testing, scripting, like what
See what the
Netflix.
breaking
Well,
point is.
Netflix actually has a suite of tools that they wrote themselves.
What were those called?
The monkey
Yeah.
tools, and so they'll test things like latency, servers going down,
It's
all
like
that
this
kind of
massive stress test on
Yeah,
the
there's
system.
like, and there's like
They-
15 different monkeys. There's like the gorilla.
Okay, and different. They
Yeah.
focus on different
Yeah.
type of things.
Yeah, so that's all people have. Plus, what people say now, like Instagram, like all these services, a lot of the enterprise services have been pretty good about kind of documenting where they failed. So it's your own testing
Right.
plus
Empirical data.
what these people have
Yeah.
said. But that's another thing for like a project like this. We probably have to put in a fair amount of time just testing the solution, just the scale, let alone
Let alone
QA
building the
type
testing
stuff.
strategies
Yeah.
for that scale.
There's going to be a fair amount of scripting involved in testing and stuff like that.
Mhm.
So this is
It's
something
not
we're-
like you can buy a billion imp devices in the first
Yeah.
place.
Test it.
So,
Yeah, just-
yeah, you'll
But
you'll need someone to be able to simulate that, possibly simulate lots of device and make them talk to the real in cloud, or your own fake
Well,
in
yeah,
cloud that
yeah,
talks
to
to
the
the
Glide
Well, we
cloud.
fake the in-cloud. We have our fake in-cloud talk to Glide, and then we
Yeah.
also have our Glide cloud and talk to our fake
Mm.
in-cloud, and see like what kind of latency we can expect on certain commands, and how many queries are lost, and what happens if we like one of them is if we jack up the latency really high between Glide and Impa, what happens? Like that's one of your monkeys, right? It's like if the latency's really high, what if the latency's really low? What if like my memory's high? What if I drop 50% of the requests I get in? What if I drop 75? Like where are my breaking points?
Or how terrible the Wi-Fi is.
Yeah, if what happens if I miss packets in the middle of this, right?
Yeah.
Well, that happened when we were testing on the TV project. You know, the phones to the TV stuff.
Yeah,
On my desktop.
Jambio.
Yeah, the Wi-Fi was so bad it wouldn't work. We had to get our own routers, right? So it's like that's an issue that you're in a million people's house or homes. So.
Yeah.
So we're way over time. Are we done yet?
Are we out of time?
Yeah. I think next step is to aggregate all our questions really and our concerns, and go from there.
Okay. I'm
Cool.
gonna drop off then. Thanks
Thank
very
you,
much.
Aisha.
Everybody else. Bye.
Cheers.
Bye. Bye.
Actually, a good theme music for this.
Thanks a lot, guys.
The A-Team, maybe.